Icebergs, so elegant and captivating, wandering like frozen stars across our southernmost ocean waters, surrounding the mysterious frozen continent of Antarctica. They draw our attention, yet only show us 10% of their whole body mass. Let's take a scientific approach to Antarctica's amazing tabular icebergs with Dr. Shuman, a glaciologist and expert in this matter. His previous work studying the layers of glacial ice in the polar regions helps us to understand how climate behaved thousands of years ago. Looking back can help us look forward, he says. After many years of fieldwork in the polar regions, he started patiently tracking the icebergs from a more comfortable environment in Greenbelt, Maryland. He's a faculty member at UMBC, University of Maryland, Baltimore County, and a research scientist at NASA Goddard Space Flight Center. Dr. Shuman or Christopher can tell us more about these wandering frozen stars.
What is A68A? This name may sound familiar to you, but it is not a new character from any Star Wars movie. In fact, it was a frozen star from social media, just for a while. A68A was a remarkably large iceberg, born and raised in the Antarctic Peninsula's Larsen C ice shelf. This name might not sound familiar to you. It calved, broke free in July of 2017, measuring about 2,200 square miles, about the size of the state of Delaware. This huge iceberg, or Big Berg, had a well-documented journey, and we can see it through remote sensing imagery from 2017 to 2021. Its meandering sailing journey went well until it approached South Georgia Island, where it fragmented into many pieces and melted away into the South Atlantic's warm ocean water. That was when and where the once frozen polar star died in February of 2021. A68A's short life inspired a rich set of questions. Where are other big bergs around the Antarctic region, and how can we know more about their journeys?
These are all the icebergs that are being officially tracked around Antarctica by the U.S. National Ice Center, USNIC, supported by other Antarctic treaty nations. Using remote sensing imagery, we can still see A23A, currently the world's biggest iceberg, covering 1,400 square miles, twice the size of Great London. It broke free from Antarctic coastline in 1986. After many years aground, it has been driven quickly, compared to human lifetimes, across the Weddell Sea. Now, it's across the Southern Ocean to the north of the remote South Orkney Islands. Further west, we can see B-22A, again, not a Star Wars character, measuring about 1,100 square miles, the size of Rhode Island, and born in early 2002 from the Twakes Glacier, its mother. At first, it was close to the Twakes Glacier where it remained grounded until the autumn of 2022, when it dragged across the seafloor into deeper water and drifted away towards northwest. We can see this journey in the animation, as it moves over time and eventually its death. Even though this sounds sad, it is a part of their life cycle.
These bergs all have a unique journey, where scientists follow their tracks and spend years taking data to make us visualize it so we will have a better understanding of where they go and why. It is their patient and continual work that we too can watch from satellite eyes in the sky.
This animated masterpiece is a perfect example that brings us back to when movies were mute, with no dialogue, just grayscale satellite images telling a story and taking us back when technology could not get us this far. Who could have imagined that we would be looking at icebergs from the sky?
Now, here we are, using WorldView data at our fingertips. This tool helps us not just to track icebergs, but many other phenomena such as hurricanes, tornadoes, wildfires, and droughts. With this innovative tools interface, we can see many things happening in our world today and in the not so distant past, helping us to predict what will happen in our future, just like Dr. Shuman said. Looking back can help us look forward.
But why study icebergs? They are a phenomenon that helps indicate how fast ice sheet change is happening. Their slow melting does not cause sea level rise, but it is the exposure of the mother ice shelf itself to warming seawaters that does. So the bigger the berg that is calved, the bigger the shelf loss, which will affect the inland grounded ice being fed by slower glacial flow. The movement of that grounded ice will cause the mass balance of an ice sheet to be affected, and this will contribute to further sea level rise.
With that being said, these icebergs show how fast the margins of the Antarctic regions are melting. Our world is changing, but it is the speed at which it is changing that is alarming. Whether we agree or not on what drives climate change in the 21st century, ice melting is happening. While we worry trying to find a solution to global warming, ice just melts. So the next time you see a beautiful iceberg in a documentary, think about these big bergs and their unique journeys and try to make the best out of yours.